Today we're going to solve radical inequalities, and you're going to see that the process is pretty different from what we did with the absolute value inequalities last unit. Let's dive right in. The process is a little bit complicated. So our first thing is to find the two critical points. Now you've never heard of those before, so let me explain what that means. The first one is we're going to set the radicand equal to 0 and solve. In other words, the first critical point is the value for x that makes this radicand equal to 0. So we're going to find that. No crazy tricks here. Just say, when does 5 minus 2x equal 0? And we'll solve that. 5 equals 2x, so x equals 5 halves, or 2.5. That's our first critical. We'll talk about what to do with that critical point in just a couple of minutes. The second critical point is from solving what we call the related equation. The related equation is kind of what it sounds like, which is the equation that is based on this inequality. We're just going to turn that less than into an equal sign. So I'm going to do this separately. 3 times the square root of 5 minus 2x minus 20 is less than 1. Sorry, it's equal to 1. We are changing it to an equation. And we're going to solve this equation using the exact same methods we learned last class. Isolate, square both sides, solve. So let's isolate. We can move the 20 over first by adding it to both sides. We can move the 3 next by dividing both sides by 3. Now's the part where we get rid of the radical. So remember that has to be by squaring both sides, and that will cancel out the radical. This one's not as tricky as some of the ones we saw last class. We don't have to worry about foiling or anything like that. And then we'll subtract 5 and divide. So those are our two critical values. X equals negative 22 and x equals 5 halves. So far, nothing crazy complicated. It gets a little bit weirder now. What we're going to do with those critical values is put them on a number line. And that will break the number line into 3 sections. Now, if there were more than 2 critical points, then we would have more than 3 sections. If there was only 1 critical point, then we would have only 2 sections. So our 2 critical points, make sure you put them in order. The spacing in between them does not matter. Just make sure you put them in order. Negative 22 on the left, 5 halves on the right. So we're setting up what's called an interval test. So that's what we're going to do now. The way an interval test works. Remember that what we're trying to do here is figure out which values for x make the inequality true and which ones don't. So the logic of the interval test is if any number, any single number up in this section makes the inequality true, then every single number in that section will make the inequality true. There's a big leap there. That's a big statement to make. If any number in this section makes the inequality true, then every number in that section will. Which means if we just check one number up here in this section, if it makes the inequality work, then the entire section, the entire space bigger than 5 halves, is all part of our solution. And if the number up there doesn't, then none of those numbers above 5 halves will be in our solution. So what we're going to do is pick a number bigger than 5 halves, pick a number between negative 22 and 5 halves, and pick a number less than negative 22. We're going to pick one number from each of these sections and plug it into the inequality and check it. Now, my advice to you, this is certainly optional, but my advice to you is to go for the easier numbers first. I always look for where 0 is first. 0 is in here. Doesn't even matter if it's evenly spaced or not. I'm going to check the number 0 the same way we checked equations in the last unit. by checking to see if when you plug in a 0, is the inequality true? Well, 3 times the square root of 5 minus 20. It's sometimes tricky because I don't know exactly what 3 times the square root of 5 is. But if I move that 20 over, you should be able to tell just by looking that 3 times the square root of 5 is going to have to be less than 21. If you're not sure quite yet, what you can do is divide both sides by 3 and say that the square root of 5 is less than 7. That is definitely true. The square root of 5 is definitely less than 7, which means that everything in this section between negative 22 and 5 is part of our solution. But that doesn't tell us anything about the other two sections, so we're going to have to check those also. So I'm going to check a number that's bigger than 5 halves. Sometimes it's easier to go crazy, like pick a really big number like 100 or 1,000, because then you won't have to do too many calculations. I'll show you what I mean. 3 times 5 minus 2 times 100 minus 20 is less than 1. Well, you can see, hopefully right away, we're going to run into a problem here. 5 minus 200 is negative 195, and I don't know if 3 times the square root of negative 195 minus 20 is less than 1. Actually, I do. It's not, because the square root of negative 195 isn't a real number at all. It can't be less than 1 if it's not real. So that means that nothing above 5 halves is part of our solution. And then the last thing I'll do is check a number that is less than negative 22. And again, sometimes it's easiest if you just go crazy here. So I'm going to go with negative 100. So that would be 3 times the square root of 5. Actually, I'm going to go with negative 1,000 to really make the point. Minus 2 times negative 1,000 is plus 2,000. Minus 20 is less than 1. And so I'm going to do the same thing I did with the pink writing, where I'm going to, even if I don't know what the square root of 2005 is, I can still move the other pieces around, and I can see, to compare the square root of 2005 to 7, well, the square root of 2005 is definitely not less than 7. So that can't be part of my solution, which means the only part of our solution is the space in between negative 22 and 5 halves, which is almost our final answer. There's just one tiny little catch you have to be careful about, and that is you have to be really thoughtful about your endpoints. With the absolute value inequalities we saw last unit, all you had to do was look and see if the inequality symbol had an or equal to, we would fill in the dots, and if the inequality symbol did not have an or equal to, we would not fill in the dots. It's a tiny bit more complicated here. With the square root, we've got two different decisions to make. One is from the critical point from the radicand being set equal to 0. For this one, we will always fill in the dot. And for the critical point that comes from the related equation, we will only include that in our solution if the original inequality included the or equal to. In this case, it did not include the or equal to, so we will leave this critical point open. So our final solution is, you can say it either as an inequality or an interval notation. As an inequality, it's an and inequality. X is greater than negative 22 and x is less than 5 halves. Or you can put it in an interval, everything from negative 22, not including 22, to 5 halves, including 5 halves. And once I just said including 5 halves, I realized I made a slight mistake right above. I forgot that or equal to there. So those are the two ways you can write your answer.